Hi, I'd like to go over the questions and answers from yesterday's Unit 1 test over volume of rectangular prisms. Starting at number 1 here, we need to figure out the volume of this prism and then show or explain our reasoning. So there are many different ways students could have determined the volume of this figure. One way is to recognize that there are 5 layers of 6 unit cubes. So 5 layers of 6 cubes is going to be expressed mathematically as 5 multiplied by 6, and that results in 30 cubic units. Using the volume formula is another method students could have chosen. We see there is a length of 5. There is a width here of 2. And there is a height of 3. And evaluating that expression also ends up with a product of 30. So there are at least a couple different ways students could have determined the correct volume of this prism. Question number 2. How many unit cubes would it take to fill up the rectangular prism completely with no gaps or spaces? Explain or show your reasoning. So in other words, students were asked, what is the volume of this rectangular prism? This rectangular prism is partially filled with cubes, but how many total cubes would it require to find the complete total volume of this prism? And again, there are many different ways students could have approached this problem. One way is to recognize that there is a base layer of cubes represented by this purple coloring I'm doing here. And there are 14 cubes in this base layer. So I see one row of 7 here, and then there's another row of 7 unit cubes here. So 14 altogether. So I see there are 14 cubes in the base, and it would require 6 total layers of the base to completely fill this prism. So 14 cubes in the base multiplied by 6 layers required to fill the entire prism here would result in 84 cubic units. Another way students could have approached this problem is to use the volume formula. There's a length of 2 cubes, a width of 7 cubes, and then a height of 6 cubes. And evaluating this expression, 2 times 7 times 6 also gives us the product 84. So, correct answer for number 1, 30 cubic units. Correct answer for 2, 84 cubic units. First question on the back page asks us which expressions represent, and that should have said the volume, sorry for that, of this rectangular prism. Select all that apply. So that select all that apply is indicating to students that there could be more than one correct expression. And in this case, there are 3 correct expressions. A good starting point for this type of problem is to simply determine the volume of the figure. We have a length of 8 units a width of 6 units, and then a height of 4. So right off the bat, I have the expression 8 multiplied by 6 multiplied by 4. Well, that expression is represented by E. Now, students may recognize the factors 8, 6, and 4 are not in the same order in the expression E, but they know from the commutative property of multiplication that you can rearrange factors and still end up with the same product. So E would be a correct expression. All right, so further evaluating this expression, we see 6 multiplied by 8 results in 48. So 48 multiplied by 4 is another expression students could have used. I don't see 48 multiplied by 4 expressed exactly like this, but students know that 4 groups of 148 added to each other is the same as 48 multiplied by 4. So C would be correct. Now, if we were to evaluate this 8 by 6 by 4 differently, instead evaluating the 6 by 4 first, we see that 8 by 24 is another expression that would result in the volume of this prism. And we see that expression in B. 24 by 8 is the same as 8 by 24. Now, if we determine the volume of this prism, we will see that the volume is 192 cubic units. So 24 multiplied by 8 is 192. 48 multiplied by 4 is 192. So knowing the volume helps us to determine that expression A and expression D are not reasonable. Expression A is 8 plus 6 plus 4. Now that gives us 18 units. 18 cubic units is much smaller than the correct volume of this prism. So A is not reasonable and students should not have selected A. For D, we have 24 by 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 24. Now, this can be expressed as 24 to the 8th power. And if you were to determine the value of 24 to the 8th power, you would end up with a number larger than 5 billion. So clearly the volume of this prism is not more than 5 billion cubic units. So D is also not reasonable. Okay, dropping down to number 4. This was the bonus question, and I always embed a bonus question in assessments, but I do not tell students at the time which question is the bonus, simply because many times when students know which question is the bonus, they will not complete the bonus. So I tell students there's no harm in trying the bonus. You will not be penalized if you missed it. You can only benefit from trying. But many times that message is not received and students will still skip the bonus. Anyway, the question reads, Nemo's aquarium is filled with 2,400 cubic centimeters of water. The base of the aquarium is 20 centimeters wide and 12 centimeters wide. Now, this was another typo I made. I had students cross out the wide here and change it to the word long. So, rereading the problem with the correct information, the base of the aquarium is 20 centimeters long and 12 centimeters wide. They needed to answer this question here. What is the height of the water in Nemo's aquarium? For me, I thought about this problem by drawing a picture of an aquarium. And this is by no means a requirement for this question. But several students did draw an aquarium to help them visualize this problem. So we have a crude looking aquarium. I'm going to add some water here. So the base of the aquarium is represented by the face of the aquarium that is being rested on. Okay, so in other words, the aquarium is sitting on the base here. So the length of the base is 20 centimeters. The width of the base is 12 centimeters. We do not know yet what the height is. But what we do know is the volume of all the water in the aquarium is 2,400 cubic centimeters. So I use the volume formula to help figure out what height is in this problem. That is by no means the only way or the preferable way students could have determined the height in this problem. So the length we see is 20, the width is 12, but we do not know what the height is just yet. However, we do know the volume is equal to 2,400. So 20 times 12 times something should give us the product 2,400. If I evaluate 20 multiplied by 12, my product is 240. And now it may become a bit more clear what the missing value for the height is. So something multiplied by 240 is going to result in adding a 0 to that 240 to make it 2,400. Another way of thinking about this is this 2 is in the hundreds place on the right side of the equal sign. The 2 is now in the thousands place in the left-hand side of the equal sign. So the 240 has increased by a power of 10, and students know that one of the patterns when multiplying by 10 is when you multiply any factor by 10, the product is simply that same factor with an added 0. So height must be 10 centimeters. Because only 10 multiplied by 240 would result in the product 2,400. So again, this problem 4 was the bonus. Students either got it and received an extra point, or they missed it and received no extra point. But no points were taken away. They could have either gained nothing or gained 1, but nothing else. Lastly, we have a composite figure. It's made up of unit cubes. Counting all the unit cubes will result in the correct volume. What I showed students today, I colored both of the prisms that I saw in this figure. And again, students may see it differently, and that's fine as long as they can determine the correct volume. In this aquamarine colored prism, I see there is a layer of 4 here, and then there are 4 layers of 4. So the aquamarine prism has a volume of 16 cubic units. The larger orange prism here, the way I am interpreting this prism is I see a layer here of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubic units, and then I see 4 layers of 10. So that's a volume of 40 cubic units. Now, when we add these together, we result in a total volume of this figure of 56 cubic units. So again, answer choices B, C, and E were correct for 3. The height in question 4 was 10 centimeters. And then the volume of this figure in question 5 is 56 cubic centimeters. Okay. Question 6 asks students to determine the volume of a composite figure. One way students could have determined the volume of this figure is to separate the figure into 2 different sized prisms. So here's one of the prisms. There's another prism there. I'll label one prism A, the other B. For volume A, I'll need to find a length and a width and a height. And I'll need to add that to the volume of prism B, which means I'll also need to identify a length, width, and height for prism B. I'll start with prism A, and these lines in blue I'm making here represent the length of A. And I can see that the length of A is 4, so if the length here is 4, the length here is 4, the length here is also 4. So each of these locations represent the same length, the same value for the length. So for volume A, the length is 4. Next, I need to determine the width of prism A. And prism A has a width labeled 5. And lastly, I need to determine the height of prism A. And prism A's height is labeled here as 3. So when I evaluate the expression for volume A, 4 times 5 times 3, 4 times 5 is 20 times 3 is 60. So volume A has, or prism A has a volume of 60 cubic inches. Prism B, I'll label these here. So prism B also has a length we need to determine. So here's the length of prism B. And it does not tell us directly what that length is. We know that the length here is 8, but that does not account for the entire length of prism B. But we do know that this length here for A is 4 because this length, and this length are each the same, and this length back here is labeled 4. So we know from here to here is 4. We know from here to here is 8. 4 plus 8 gives us 12. So the length of B is 12 inches. To determine the the width of B, notice that the width of A is labeled as 5, and that's the same width as B. So the width of B would also be 5. And then lastly, we have a length that we need to determine for B, and that's labeled as 6. So evaluating B, 12 times 5 times 6. 12 times 5 is 60, times 6 is 360 cubic inches. And when we add volume A and volume B, we add 60 cubic inches to 360 cubic inches, and that gives us 420 cubic inches. It's 420 cubic inches. Question 7 states a preschool is building a sandbox. Below is a diagram that shows the side lengths of the sandbox. What is the volume of the sandbox? Explain or show your reasoning. Again, this is a composite figure. It's made up of more than one rectangular prism. And so I am going to divide or break apart these prisms by drawing a line across here. This is one way students could have chosen to separate prisms in this figure. Again, I'm going to color my prisms so it's easy to tell where they are, where they start, where they begin, where they stop. And that's going to help me determine the correct dimensions for each. I will determine the volume for each prism and then add the two separate volumes in order to determine the total volume of this figure. Again, I'm going to label each prism, and in the end, once we've determined the volume for each prism, we'll add them together to find the total volume. In order to figure out the volumes for these two figures, we need to determine the dimensions. For A, there is a length represented here and here. That length is labeled clearly as 7 feet. Next, we need to determine the width of A, which I'm showing in blue here. And even though there's a 10 back here, that 10 is referring to the width from the beginning of B to all the way to the back of A here. So the width that we're interested in for A is 6 feet. And lastly, we must identify the height of A. And that is not labeled over here. But this height here for B is the same value for A. So the height for B is 2, so that means the height for A is also 2. All right. So we have an expression for A. If I simplify or evaluate that expression, 7 and 6 multiplied together gives us 42, multiplied by 2 is 84 cubic feet. So A has a volume of 84 cubic feet. Next, we're going to find the volume for B. Here is the length for B. It's visible in 3 places. Each place has the same value, which means the length is 5 feet. the width are these measures here. Now again, the width is not labeled for B. But knowing that the width of A is 6, and knowing that the width for the entire figure on this side is 10, this width for B must be 4. Because 4 added to 6 gives us this total width of 10. And lastly, we know the height is 2, because the height for A was 2, and we figured that out by looking at the height of B. Evaluating the expression for volume B, 5 multiplied by 4 multiplied by 2 results in 40 cubic feet. So to find the total volume, we must add 84 cubic feet from A, 40 cubic feet from B, which is going to give us a total volume of 124 cubic feet. So, answer for 6, 420 cubic inches. Answer for 7, 124 cubic feet. Question 8. Select all expressions that represent the volume of this rectangular prism in cubic units. Once again, I'm going to determine the volume of this figure. The volume can be determined using the volume formula. There is a length of 1, 2, 3 cubes, a width of 1, 2, 3, 4, 5 cubes, and a height of 1, 2, 3, 4 cubes. 3 times 5 times 4 is a correct expression. We see that here, 3 times 4 times 5. Remembering that 3 times 5 times 4 and this expression are the same due to the commutative property of multiplication. Further evaluating 3 by 5 by 4, we find that the volume of this prism is 60 cubic units. B would give us 12 cubic units, which is much less than 60, so B must be eliminated. C, 20 plus 20 plus 20, does give us 60 cubic units, which is correct, but to understand where 20 plus 20 plus 20 comes into play in the problem, you'll notice that I colored in a layer of 20 cubes here. So there's 4 cubes going up, 5 cubes going back, so that gives us an area of 20 cubes or a volume of 20 cubes, depending on how you want to think about it. There are 1, 2, 3 layers in this prism, so 20 plus 20 plus 20 does match and represent the volume of this prism. Answer choice D has us multiplying 15 by 15 by 15, which is the same as determining the fourth power of 15. This gives an answer somewhere in the 50,000 range, which is much too large to represent this prism. And lastly, 5 by 12. Well, knowing the dimensions are 3, 5, and 4, 3 and 4 gives us 12, and we would still multiply it by 5, and 5 multiplied by 12 does give us 60. So all reasons why the expression 5 by 12 is correct for this question. The last question, how many cubes make up this Rubik's Cube? How did you figure it out? There are 3 cubes making up the length. 3 cubes making up the width, and then 3 cubes making up the height. If we use the volume formula and plug those values in, we see there are 27 cubes. Students may have also recognized a layer of 9 cubes here with 1, 2, 3 layers going back. So again, 9 times 3, 27. There were multiple ways students could have determined the number of cubes in this Rubik's Cube. So again, question 8, the correct answers were A, C, and E. And question 9, the correct volume, or I'm sorry, the correct number of cubes that make up this Rubik's Cube, 27. If you have any questions at all about why a question was missed, how many points were taken off, if you'd like to see a problem works out a different way, please let me know, and I can make that video for you. Hope this helps, and have a great day.